Welcome to Summer Supplement. Still in Lesson 1, but this is the second session. Alright, remember where we stopped yesterday? Was that you have to factor first before you begin to cancel. And we looked at an example where we factor first. There we go. You factor the first, and then you can cancel out, and that's not a problem. But remember also that if you don't factor first and you try to cancel out a term rather than a factor, you get something that is not correct. So I can't emphasize this enough. Factor first before you begin to cancel. Alright, let's get ready and look at a brand new example. We'll take a look at this one. And notice here we have a numerator and a denominator that can be canceled or can be factored. So when we look at it though, the polynomials are not in descending order. You're going to save yourself a whole lot of trouble if you put the polynomials in order so that the terms are descending. So in other words, this negative a to the fourth should come before 3a to the third. These terms are descending, so that's fine, but we want to put them into descending order first. Now, what we also notice is when we do that is that you have a negative out here in front of the first term. So when you factor, always make sure that you factor out that negative. Once again, that's going to be a big help in making sure that you always have factors that can cancel. So in the numerator, when we look at that, we find that you have an a in common, so we can factor out that a. There's actually three a's that are in common, so we can factor out a negative a to the third power. And in the denominator, we had 2a to the second, which is in common, and we could factor that out. So when I factor out a negative a to the third, remember I said we want to get this negative so that we will find things that can be canceled. Negative a to the third times a gives you negative a to the fourth. Negative a to the third times negative 3 gives you positive 3a to the third. 2a squared is in common for both of these, so we can factor it out. Remember, you're always asking yourself, the thing that I factored out, what can I multiply it by to get this original number, or this original polynomial? So 2a squared is multiplied by a to get 2a cubed, and 2a squared is multiplied by 3 to get negative 6a squared. Now, we have to be a little careful with this. I want you to notice that there is something in common in the numerator and denominator. And this is just that thing I was saying about if there's a negative first term, factor out the negative. It makes the common factors easier. Now what we see here is that we do have a common factor. We have a minus 3 and a minus 3. Once you have factored the polynomial, the pieces that are multiplied together are all factors. So there are 3 a's here and a factor of a minus 3. You also have a negative 1 hiding in here as a factor. In the denominator you have 2 as a factor, and we also have 2 a's, and we have a minus 3. So anything that is in common in the numerator and the denominator can be canceled. Okay. Notice a to the third, a squared, you cancel that like we always have. We have 3 up here and 2 down here, so there's 1 left over up here. 3 up here, 2 down here, 1 left over up here. There's nothing to cancel out as far as numbers, so far we've got this. Now the other thing that we notice is that a minus 3 is a factor. So since it's a factor, it can be canceled. So a minus 3 can be canceled. So our final answer here is what's left over after you cancel. What we could have done is we could have done all that canceling right back here in this step. However, just in the interest of having you see what's going on, I did choose to do it in 2 steps here. But whatever is left after you cancel out all of the factors that are in common in the numerator and denominator is your final simplified answer. So this really, when you boil it down, is nothing more than this. Now there is a technicality which, once we get this part down, once we get the factoring and canceling, we will be able to bring in some numbers that will make this a false statement. But we have to, first of all, we have to be able to get your basic answer before we start looking at exceptions. So your job will be factor, cancel, all of the things that are in common in the numerator and the denominator. And if you need to see that written out a little bit more as far as the factors go, let's put in one more little step here. If this 3 and the 2 confused you a little bit, this is really -1 times a times a times a minus 3. And this one is 2 times a times a times a minus 3. And once again, we can begin to cancel there. One a cancels, another a cancels, a minus 3 cancels. What you're left with is -1a and a 2 down there. Okay, we just don't want to forget our shortcut with these exponents, but I also didn't want anybody to get lost either. Okay, so this is the longer way of writing it. If you need to write this step until you are super confident in these, or if you're looking at the practice problems and you're seeing that you're not quite getting it, write it out in the super long form until you can actually see it all. Alright, let's take a look at another example. Alright, this polynomial divided by a polynomial. Notice that in the numerator it's pretty easy to see that there's things to factor. The denominator, however, can also be factored. We're going to take this opportunity to do a little bit of a factoring review. However, if you find yourself having trouble remembering all there was to factoring, you can always go back to the Algebra 2 tab and click on the lessons from Chapter 5, Section 4 regarding different methods of factoring. Let's take a look at that numerator first. We factor the numerator. Take a look at that. We have 2x squared plus 2x. So that one's a little easier to see. We have a 2x that's in common. So you factor out the 2x. 2x times x is 2x squared. 2x times 1 is 2x. So you're always looking for what is in common between both the terms and factoring that out first before you even start any of the other methods. So you then want to rewrite the numerator in terms of its factors instead of in terms of the original polynomial. So the next thing we need to do is take a look at this denominator and begin to factor that. Notice it's a 4-termed polynomial. And when we're looking at a 4-termed polynomial, if there's nothing in common across the 4 terms, which there isn't, the thing that you need to do next is factor by grouping. So what we have is we have 2 groups of 2 terms here. So we can put the x cubed plus x squared together and the negative 4x minus 4 together. But if you'll recall, it's a little bit easier to change this to a plus negative before you start to factor, just to make it, once again, so that the factored form will come through a little bit more easily. So here's my group. I've got this as a group, change this to a plus negative, and then here is my second group. Factor that one by itself. X squared is in common, so x squared times x is x cubed. X squared times 1 is x squared. Then you look over here and there's a negative 4 in common. Negative 4 times x is negative 4x. Negative 4 times 1 is negative 4. Now, the good part is that when we did that, we have an x plus 1 that is in common. It is also a common factor. That's why factoring by grouping works. It works when you have a polynomial that has 4 terms, or sometimes it's a step in factoring a trinomial for specific types. So x plus 1 is in common. That means that x plus 1 is multiplied times x squared. It's also multiplied times minus 4. So far we have x plus 1 times x squared minus 4. Now this particular polynomial right here, this one is special. You always want to make sure that you have factored completely. This polynomial can also be factored. You need to remember to check for things like difference of two squares. X squared is a perfect square. This is also a perfect square. 2 squared is 4. So this is a difference of 2 squareds. And if you remember, there's a special format for that. It means that this is really x minus 2 times x plus 2. X squared minus 4 is really this in its factored form. Now, as I said, if you forget those things, go back and watch the lessons on factoring, or look at the lessons on factoring if they're not in the audio recorded form. So this entire group of factors here is the completely factored version of this polynomial. So you want to put it into the problem where it belongs, because you've just done the work to factor it. Then after you have factored both polynomials, you've got factor, 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 factor. You can then begin to look for things to cancel out. X plus 1 cancels out. It's a factor, so you're allowed to cancel it. So the answer then is what's left over. 2x is left over in the numerator, x minus 2 and x plus 2 in the denominator, and there's nothing else that you can do with that. Don't fall into the trap of thinking, oh, I see a 2 up here and a 2 down here, they can cancel. They cannot. 2 is a factor up here, but 2 is not a factor by itself in the denominator. 2 is a term in a part. Okay, it's a term. It is a part of a factor. Here, this 2 is a part of this factor. It is not a factor by itself, so therefore it can't cancel. So this one is the actual answer to that problem. Okay, I'm just going to give you a couple of, before we hit our next example, give you a couple things here to think about. We will be, as I said, we will be making a little bit of an addition to the answers we've been finding by the time we get to the very, very, very end of all of this particular lesson 1. However, we got to get these basics of factor and cancel down first. And once again, if you forgot anything about factoring, go back on the Algebra 2 tab on the website and look at those lessons on factoring again. Alright, so here we go. On to the next example. You can actually multiply two rational algebraic expressions, as we said before. We could cross cancel, but before we do that, we have to factor each one of these polynomials. Okay, so I want to run back through. We'll use this as a little bit of a factoring review. As we factor this first polynomial up here, w squared minus 11w plus 24. Remember, you're looking for factors of 24 that when you add them together, you get this middle number. So a negative times a negative makes positive 24, and then when you add these two together, you get negative 11. You might have to do check a few that are not before you find the one that works. But since there's a 1 coefficient here, these two numbers that you found become part of the binomials that when you multiply them together, you get this. So here is our factor, our factored form of this polynomial, and it belongs up here. Now let's take a look at the next one. You're going to want to factor this right here. Once again, you're looking for factors of 80 that when you add them together you get negative 18. Negative 8 and negative 10 work for that. We got negative 18, so here's the factored form of this polynomial right here. So once again, we put that in. And do make sure that you're taking time to write these things down. Listen to the explanation, then write it down, or try to anticipate what's going to be done before it's done, but make sure that you're writing it so that you can reinforce it before you move on to the next thing. Alright, the pause button will be your friend as you go through this. Alright, we need to factor this polynomial now. Remember, we're going to look for factors of 50. When you add them together, you get negative 15. Take a minute and think that through. What two numbers could they be? Negative 5 and negative 10. Multiply them, you get 50. Add them, you get negative 15. Once again, here's our factored form of this polynomial. So it's going to belong up here. And finally, the last one. We're going to factor w squared minus 9w plus 20. Negative 5 times 4 gives you 20. Add them together, you get negative 9. And here is your factored form. Now what you really can do if you're not sure if you've gotten the correct factored form is you would go back and multiply them together to make sure that it gives you that. So we put that last one in. Okay, now that you have factored everything, this is the point where you can look for things to cancel. W minus 8. These are factors, so therefore they can be canceled. Then you can check W minus 3. Is there a partner for that? No, there is not. But W minus 5 is found in numerator and denominator. And then you can also look across to the other fraction to see if you have anything to cancel, and you do. So those things cancel. And once you've gone through and checked to make sure that there's nothing else that's in common in the numerator and denominator, that's when you say, okay, now I need to write down what's left over. So W minus 3 is left over in the numerator. It hasn't been canceled. W minus 4 is left over in the denominator. It has not been canceled. And that gives you your answer. W minus 3 over W minus 4. Notice I didn't write the parentheses around the W minus 3 or the W minus 4. You need to keep in mind from way back that this large fraction bar is a grouping symbol. So the parentheses are implied here. As long as you just have that factor down there, and there's nothing else along with it, no other no other factor had to come along with it. You don't have to write the parentheses. As a matter of fact, it's more correct not to. So that's your final answer on that one. Let's take it and look at a new one. Notice this is very similar to the last problem, except that it's a dividing problem instead of a multiplying problem. If you recall from your past history, every division problem is actually a multiplication problem. All you have to do is take the reciprocal of this fraction that comes right after the dividing sign. To change a multiplication, change to a multiplication problem and use the multiplicative inverse, we call that, or the reciprocal of the second rational expression. More common terms, you're going to flip what comes after the dividing sign. So we do that first. Before we start to factor, before we start to cancel, you want to make it so that it's a little bit more readable. So we flip over that second fraction, and after that you need to factor. So I had shown a little bit more of the work in the last one as far as factoring goes, but I want you to do these factorings by yourself and then check them to make sure that they're right. But you do them one at a time. In the interest of time, I've done them all here. X squared plus 2x minus 8 comes out to be x plus 4, x minus 2, because 4 times negative 2 is negative 8, but when you add 4 and negative 2 you get positive 2. This one, 3 and 1 multiply together to get 3, but when you add them you get this middle term 4x. This one, 3 is in common, so it can just be factored out. 3 times x is 3x, 3 times 1 is 3. Now this one's a little bit interesting. You do not have to write this 1 times parentheses x minus 2. The only reason I did that was to emphasize that the fraction bar is really a grouping symbol. X minus 2 is really a factor, and that's really something that's important to understand. It's a factor because you can factor out a 1. 1 times that thing in parentheses. That's the only thing that goes into x and negative 2. But if you can see it in the parentheses, it helps you to identify it as something that is in fact mathematically legal to cancel out. So now that we have that all factored, and we're keeping in mind that this is actually a factor here, now we can begin to cancel. So we'll look through x plus 4, there's nothing that we can cancel that with. X minus 2, yeah, there is one in the denominator, that can go. X plus 1, there's a partner down here, so they can get canceled out. There's nothing to cancel with the 3, and there's nothing to cancel with the x plus 3. So we have to leave those alone. So the answer comes by taking what's left over. What's left in the numerator is a 3 and an x plus 4. Now if you do have a regular number, that should always go before any kind of binomial or trinomial or polynomial that may be left over. The 1 times anything is itself, and remember, I don't have to put those parentheses in because the fraction bar is its own grouping symbol, and that's important for you guys to remember. Okay, we're moving along very well in this lesson. We need to now take a look at complex fractions. Complex fraction is a fraction divided by a fraction. This is the simplest type of complex fraction, if you can have a simple complex, but that's what it is. So you've got 3/8 over another fraction 9/16. We don't like to see it in that form, so it's going to have to be solved. You need to remember that any fraction bar can be thought of as a division sign. So we want to rewrite it as a division sign, and it's going to make this problem very much easier. Watch out for these complex fractions. Complex fractions are very easy to make a mistake in unless you do that rewriting step. This is 3/8 divided by 9/16. And then it's easy to handle. Then you know that you take the second fraction, you flip it over, and then you can look for your numbers to cancel. For example, 3 and 9 will cancel, 8 and 16 will cancel. 3 and 9, 8 and 16. And then you're left with just 2/3 in this one. It's super simple when you have just numbers, but we need to make sure that we're also keeping in mind that you can sometimes have polynomials in complex fractions. So we need to apply that same idea to a polynomial. So here's a good example. It's a complex fraction because you've got a fraction divided by a fraction. So this just kind of looks like a whole tower of numbers, so we want to rewrite that, remembering that this is a division sign. So we rewrite, and when we rewrite it, here's our numerator, divided by, that's this symbol, and here's the denominator. Please be careful with these things. Writing this step is important so you don't confuse yourself. Okay, writing this step is important so that you don't confuse yourself and accidentally come up with a wrong answer. So now that we have it as a division sign, you can change it to multiplication and flip that thing over. Okay, so rewrite is multiplication. So we have one rewrite and follow it up directly by a second rewrite. 5a squared minus 20 over 2a plus 2, that's that part, times, flip it over, so 4a comes to the top, 10a minus 20 on the bottom. Now after that, we need to begin to factor. 4a is already factored, we don't have to worry about that, but there is something that can come out of this. There is something that can come out of this. There is something that can come out of this. Okay, so the 5 comes out, a squared minus 4. 2 comes out, a plus 1. 4a stays itself, 10, a minus 2. But when I say factor, I mean factor completely. One of these locations has something that can be factored a little bit more. Before I tell you which one it is, think it through and think about which one could be factored just a little bit more. That's right, it's this one. This one can be factored further. Okay, think for a minute, what is special about it that makes it able to be factored further? That's right, it's a difference of two squares. Difference of two squares. So when you factor that further, a squared minus 4 becomes a plus 2 times a minus 2. Now it's factored completely. Only when it's factored completely should you begin to look for things to cancel. Only when it's factored completely should you look for things to cancel. So here we are, and we can begin to cross out. A minus 2 jumps out at you. You can cancel that out. We can look, we see the 5 will cancel with the 10. We can see that the 4 is going to cancel with the 2. And we could get kind of fooled into thinking we got everything in that step. But take a look. There's a 2 here and there's a 2 here. Even though you've canceled once, you can look back and see if you can cancel a second time. This 2 and this 2 can also be canceled. You can cancel out numbers twice. But you're not canceling the original, you're canceling the thing you got after you canceled. So the 2 and the 2 will cancel each other out. So then you need to evaluate what you're left with. You're left with an a plus 2 and an a. Traditionally, this a is going to get written first. And then the denominator, you're left with an a plus 1. And that's all taken care of right there. Now this is a really good stopping point for this lesson, so I'm going to close this one up right here. What you really need to do at this point is you need to go into the practice problems section on the website. There's 3 lesson section practice problems. And you need to go through and you need to practice all of these skills of factoring and canceling. Each problem is presented as a problem, and then the complete solution with the steps is shown afterwards. So you need to go through, make yourself do it, make yourself take your time, as much time as you need to be able to get through everything. You will get to a point on that where it says, now we're going to look back at all the problems, and we're going to do that one detail up that I've been talking about. So at this point, after this lesson, I want you to go through, do all those problems once with just the factoring and canceling. That'll take you a good long time. And then I'm going to ask you to, once you've done that, I want you to watch part 3. And part 3 is going to take you just that one more step that moves you into the pre-calculus mode of thinking. Alright, have a blessed day in whatever it is that you are doing.